So, topic IoT integration with cloud services. We are going to discuss this is little information about me. Yeah. So, we are going to talk about the role of cloud computing in the IoT, how and where this cloud computing is going to be useful for us in context of IoT, and then what are the cloud platforms we have specifically for IoT like AWS IoT, Azure IoT and so on. Then we will be talking about storing and retrieving IoT data from the cloud, how you load the data from IoT devices to the cloud and from the cloud to the IoT devices, right. And then we will see hands on in AWS, how we load the data and how we do the analytics part in the cloud platform, the data which is received from IoT devices, right. So, this is going to be our discussion the whole day. So, 4 hours of lecture we will see these two in this session, right. Before I go and talk about what is cloud computing or what is IoT, right, I want to introduce or I want to kind of revise some terminologies which are necessary for you to understand the concepts of both IoT with cloud, right. If you want to know how IoT can be integrated with cloud, there are some key parameters which you should be knowing. These are all computer science specific, they do not have any, they are used in IoT and cloud, but they are independent of those things. When I talk about how IoT can be integrated with cloud, I will be talking about all these key terms, okay. So, which are very generic and can be used in different technologies. So, I will like to introduce them or kind of revise them quickly what each of those key terms are, so that you understand my lecture very well or the concept of IoT with cloud very well. So, first one is hypertext transfer protocol, HTTP. We know this very well, right, but just I am trying to revise those things to understand how these things works, so that you understand better, right. So, this is mainly used for communication between two different websites, okay, two different pages communicating, two different services communicating, wherever there is a communication between a client and server. You can see this diagram here, HTTP connection, there is a client and there is a server. Client is sending a request and server is giving the response, right. So, this is one of the standard protocol what we have for web communication used in websites and APIs, right. So, how is this going to be used as for IoT? IoT devices send data using HTTP request. So, here in this diagram you are able to see a client and a server, but in our IoT perspective there will be an IoT device, which will be sending the request or sending the data and getting the data from the cloud. So, this communication will happen using this HTTP protocol, right. So, just want to introduce this, what is HTTP? It stands for hypertext transfer protocol. It is a very important network protocol which is used for web communication, communicating between two different parties, right. So, how it is going to be used? See, IoT devices send data to the cloud servers using HTTP. So, in place of client I will be having IoT device which will be sending the data to the cloud server. That communication happens using HTTP. Next, HTTPS, just I am adding a term secure, right. This is not this is used for communication, but this is a secured version. If you see here, HTTP plus the secured socket layer is equal to HTTPS. So, this is one network layer, we add little security to this existing HTTP, it becomes HTTPS, right. So, this is a secured version of HTTP which uses SSL and TLS encryption to protect the data. It means when the IoT device is sending the request to the server, right, that message which is going is secured. It means it is encrypted and nobody can access that. So, only thing when HTTP connection is there, somebody can understand this request and response, what data is being loaded, but when I am using HTTPS, the secured protocol, no, we cannot access it, right. So, imagine a diary with a password, a simple example. If someone tries to open it without permission, they cannot read your secrets, because it is having some this security on top of it, okay. So, how is this HTTPS used for us in IoT with cloud? HTTPS encrypts the communication, preventing hackers from reading data sent by IoT devices. It means when IoT devices are sending the data continuously into the cloud server, that communication happening between the IoT device and the cloud will be secured if we are using HTTPS. Okay. So, let us go through few key terms. Next one is MQTT. Okay. These are very generic and can be used in any context, anyway, not only in IoT or cloud, but they are frequently used in different software systems. But for us to understand how IoT is communicating with the cloud, we need to know some terms. That is what we are trying to see. So, the third one is MQTT, Message Queuing Telemetry Transport. It is one of the messaging protocol which is used in IoT communication. Okay. How and where it is going to use, and right, it works on publish subscribe model, right. So, you see the simple example here, a school announcement system. What is this MQTT? What is the purpose of this MQTT? How does it works, right? So, imagine a school principal making an announcement. What is that announcement? The principal publishes a message, sports day is on Friday. Teachers in different classrooms receive the message, and the students now know about the sports day without asking directly. So, something has been broadcasted, right. So, there is a publisher who is publishing, that is the principal, and there are subscribers. You see, principal is the IoT device which is continuously sending the message, and there are cloud subscribers who are receiving the message, right. From there are some end users who are getting that information. Okay. So, MQTT is a messaging protocol which is used for communication between an IoT device and a cloud subscriber, or from an IoT device to a cloud server. So, device is sending messages continuously, there is a subscriber, there is somebody who is waiting to receive that message. They are getting that message, they are receiving the message continuously from the publisher, right. So, MQTT is that protocol which plays the game in publishing and subscribing the messages. So, you see, this is an example of that MQTT. How does it works? You see, there are different kinds of sensors. You might have already studied about different types of sensors. So, there is some temperature sensor, moisture sensor, a speed or accelerator sensor, right. They are publishing that message continuously. So, there is one MQTT broker which will be receiving those messages and sending it to the subscribers. So, there is one cloud server which is now subscribed. This cloud server is subscribed to receive messages only on the accelerator. Okay. They are only on the accelerator, right. So, this message from accelerator, this 1.8G is published into the cloud server. Why? Because they have received it, they have subscribed that. Okay. Next, if you see this example here, this one more value is subscribed to temperature. So, whenever this sensor is publishing the temperature, this MQTT broker is the kind of protocol. This message will keep coming here, and from here the subscriber who has subscribed, it's same like your YouTube. You subscribe to a channel, you keep getting those on your browsing page or the landing page, home page. You see those videos first for which you have subscribed. In the same way, messages are being pushed into the broker, and there are some subscribers who are looking for those messages only, right. So, this is MQTT. This is going to be widely used protocol in IoT with cloud. Next, TCP. These are all again some relevant protocols of network what we have, but we need to understand this also, because we are going to send the information from the IoT device, from the IoT devices to the cloud. When I am trying to send that message to the cloud, all these protocols comes into picture, because it is happening through the network, right. So, TCP is one very common protocol. I hope everybody is aware of this transmission control protocol, right. This is our TCP ensures that IoT data is delivered completely, right, full message transfer. Some IoT device is sending some information that is fully transferred into the cloud server. TCP helps in doing that, right. There is something called UDP, user datagram protocol. This is a alternative for TCP, but it does not guarantee 100% message delivery, whereas TCP guarantees 100% message delivery, right. So, TCP ensures reliable communication between IoT devices and the cloud. Okay. Data is sent in order and without loss. It goes in a sequence, whatever order the IoT device is sending, in the same order it will be received without loss. Next, UDP, that's what I was saying. This is alternative for TCP, but again, but it is less reliable. Sometimes, no, since we are learning TCP, it is important for us to know about UDP as well, right? So UDP sends IoT data faster, but without guarantees. So based on our requirement, sometimes we have to use TCP or sometimes we have to go for UDP, but obviously TCP is the one which is most widely used protocol. Next, COAP, right? Constrained Application Protocol. Very important, like MQTT. This is also one more important protocol which we are going to use it frequently. What is this COAP protocol? A lightweight HTTP alternative designed for low power IoT devices, right? Same alternative, this again lightweight HTTP. What is the use of HTTP? It is used to transfer the messages from the IoT devices to the cloud server, right? Request and response between IoT devices and the cloud server happens using HTTP. So this COAP is an alternative for that, right? Mainly used for low power IoT devices, meaning for small IoT devices, right? This COAP uses UDP instead of TCP, making it faster for real time IoT applications. Okay. So, for example, walkie talkies, we know about these walkie talkies. No, it is in sync, we do it very faster, communication is very fast, and it is live. You need not connect something. You need, like you dial from your mobile phone, you call to somebody, you have to wait till it connects the network, then it rings, and then the other person responds. But here it is not like that. It is continuous. It is in synchronous mode. You give the message, automatically you get the response, right? So COAP is like walkie talkie, allowing IoT devices with low power to quickly exchange short messages. Okay, so when there are IoT devices, they want to, if you take an example of a smart home, from your mobile device you want to switch off the washing machine, or you want to switch off the AC, you are clicking a button here and it is getting impacted there, right? So this quick synchronous message passing or the synchronous communication is happening between IoT devices to the electronic or anywhere where the data is stored. We go for Constrained Application Protocol, COAP, right? So you see, smart street lights use COAP to send data to central cloud server. Okay, one more application where street lights send the messages to the cloud server using COAP. So they send the messages, they give the information, right? So this is about one more protocol which we will be frequently using in our IoT with the cloud. Next, TLS, Transport Layer Security. Okay, maybe these terms I am explaining independently, but once we enter into the actual picture, these things are required for you to understand how what are each of these terms, right? So IoT devices must securely connect to the cloud to prevent cyber attacks, that we have seen, right? So TLS is a transport layer security. Okay, so it is used on top of HTTPS or MQTT, right? Provides end-to-end encryption for secure communication. So this transport layer, when the actual data is being transported, there the security is formed with the help of this TLS, right? TLS ensures only trusted devices communicate securely. Only trusted devices can talk to each other in the network. For that we use this transport layer security, right? So another application could be a smart sensor uses TLS to encrypt data before sending it to AWS IoT. Suppose you are loading the data into AWS, you are using either AWS or Azure or Google Cloud Platform. To send the data, we have to, a sensor will be using a TLS to encrypt the data before actually sending to the cloud server, right? So this is used on top of these HTTP, MQTT and other cloud related APIs, TLS. Next one, SSL, Secure Socket Layer. Again, this is an older version of TLS, not preferred, but just I am showing because lot of theoretical concept when we talk about IoT integrating with the cloud, we talk about TSL or SSL, right? So Secure Socket Layer was an earlier or an older version of TLS. Okay, so this has been used earlier, but once this TLS has come into picture, right? Everything is being in sync. Next, FOTA, right? So some new terminologies, firmware over the air, right? FOTA. I will be talking about these things. Allows remote firmware updates for IoT devices. Okay. So, remotely, let's see an example how where it is going to be used. FOTA updates IoT devices remotely. Some IoT devices, they need some update, right? This FOTA helps for us in updating those devices. Okay. So, reduces the need for manual updates, improving security and performance, right. So, this is one of the, again it is one protocol which will be using where it will be helping us to update the IoT devices. See, maybe you might have seen lot of examples in smart agriculture or smart farming, right. Farmer is sitting in his home, he's sitting in his home, and farm is somewhere here very far, right. So, there are sensors installed here, there are sensors installed in the field, right. So, if they need some updations, FOTA plays the game. From here, sitting here, I can update that devices, right. So, a smartwatch receives automatic bug fixes via FOTA updates. You need not manually take this out and fix it. Automatically, when it is connected to the cloud, when it is connected to the network, it gets updated. That update happens with the help of this FOTA firmware over the air. It's like on the go. Over the air means then and there itself it happens, right. So, a simple example, again it's a very nostalgic thing when you talk about Mario video game, right. Sometimes it is that mushrooms and gets stronger. When the game is moving on, in between it gets some mushrooms and it gets stronger, right. On the go it gets that. You need not restart the game, once it is getting energized or it is getting stronger. Same way, IoT devices need not be fixed manually. Automatic updates can happen with the help of this FOTA, right. You understand these things in bigger picture once you move forward. Next, OTA, over the air updates, right. Similar to FOTA, but includes both firmware and software updates. Okay. So, software updates in mobile phone, we get software updates, right. So, those software updates also and the firmware updates are automatically done with the help of OTA, right, used in IoT devices like smart TV, smart home hubs and connected vehicles. Okay. So, we need not do the updations, right. So, both are same, FOTA and OTA, they are used for updating, right. Some of the IoT devices need some update to be done, that will be done remotely, automatically it will be done, we need not worry about it, right. OTA allows IoT devices to receive updates remotely. Okay. So, it talks about both firmware and the software updates. SDK, the most important one in today's discussion will be SDK. What is this SDK? Software Development Kit, right. This is very, very important. The biggest question in integration of IoT with cloud is answered with the help of SDK, right. People have been talking about IoT to you. There are a lot of sensors, there are a lot of electronic components like Raspberry Pi, there are so many MCUs, microcontroller units are there. That hardware part you are aware of that IoT, right. But when that how is that hardware component is connected to a software component or the cloud, right. This connection between the hardware component or the electronic equipments related to IoT or the sensors is connecting with the cloud, that is with the help of SDK, Software Development Kit, right. So, every cloud provider has their own SDKs. Suppose I am having a Raspberry Pi with me, right. I am having a Raspberry Pi kit with me, I want to connect it to the cloud, maybe for example AWS, and I want to do that programming using Python programming language, then I have to download the AWS Python SDK for IoT. I have to download the AWS Python SDK for IoT. This is again a package, we have to download it and install in our local machine when you are connecting it to the cloud, right. So, what is this SDK? General term SDK, Software Development Kit, collection of tools, libraries and APIs to develop IoT applications, right. So, cloud platforms like AWS, Google Cloud, Azure provide IoT SDKs to simplify integration. Whatever information or whatever connections I am having in that Raspberry Pi board or that all those sensors, right, that should be understood by the software side or the cloud side. right? So we need SDKs, which we are going to see today. We'll be downloading some SDK and running, we'll be writing Python program, which will be receiving messages from here, and it will be loaded into the, pushed into the cloud. Okay. So if somebody wants to load them information into the mobile, they also can, they have to use the SDKs. So a developer uses AWS IoT SDK to connect a smartwatch to the cloud. So he has a smartwatch here, right? There is a watch. No, from this watch I want to send message to the cloud. To do this, I should have an SDK in between. With this help of this, I can connect these both. They can talk to each other, right? It's kind of a, if you understand cloud, maybe kind of a hypervisor or a software, right, for virtualization, right? In between, it falls in between the hardware and the software component, you can assume in that way. That is our SDK. Next, API, very common term. API request, API response, API, we all frequently we keep using this term, application programming interface, right? What is this API? Okay, a set of rules and endpoints, set of rules and endpoints that allows IoT devices to communicate with the cloud, used in data transmission, device control, and cloud analytics. So API could be a request. So if there is a client here and there is a server, in normal terms, client sends an API request, server gives an API response. So it's kind of a broker in between, which will carry the messages from the client. It will carry the details of the server, where the request is going to. It will also carry the question, what actually I am looking for, right? All that is carried from the client to the server using the help of API. We call that full set as an API, right? So it's as simple as that. You see this example, you go to a restaurant, you ask the waiter you tell the waiter what food you want. You giving API request, you are giving your scenario. The waiter gives your order to the chef, cloud processing. So the request has gone, waiter brings your food to your table, API response. So see, API doesn't simplifies about communication, it's also talking about along with the communication, carrying my information and bringing back what I need, right? So APIs help IoT devices request and receive data from the cloud services. So this is again, in a simple terms, I will say HTTPS is a protocol which is used for communication. So when this protocol is used for communication between A and B, right, the request which A is sending using the help of HTTPS to B is called an API. The request which A is sending to B using HTTPS is called an API, and the response which B is giving to back A using HTTPS is also called an API, right? So it is including everything, what connection to use, what message is being sent, and to whom it is being sent. That whole point, that whole package is called an API. It carries your request and it brings back your response. Okay, so this is API. So these are a few key terms. If I quickly summarize what we have seen, we have discussed about HTTP transfer protocol and the secured version of this HTTP. Yes, then MQTT, very important, messaging, queuing, telemetry transport. This is used for communication between IoT devices, which follows publish subscribe model. This is the ultimate one. We are going to use this MQTT only for communication between the IoT devices and storing the data in the cloud, because it is synchronous. Live data is coming to me, right? When Tesla car is running, it is working, it is running on the road, it is automatic car driving is happening, then it is sending the message automatically. The data is being sent to the cloud is doing the processing based on the business rules, it is giving back the response very quickly. So MQTT broker helps in sending the data from the IoT devices to the cloud, and in the cloud the decision making happens and you get back the response, right? So these are different protocols. SCOPE is one protocol, TLS, SSL are security layer, transport layer protocols, then FOTA and OTA. These are for sending the updates, software updates automatically to the IoT devices as well as the software components involved in the IoT to cloud integration. SDK, very important one, software development kit. This is it says kit, but actually it's a package which we can download and execute, run that program. That program will receive the input from the IoT devices. It also will have the content or the details of loading the data into the cloud. Okay, so this is one of the most interesting thing what we are going to see today, how IoT data is being pushed into the AWS or some cloud platform, right, and the API. So these are key terms in the IoT with the cloud, because when we are going to understand what is IoT, what is cloud, how are they talking to each other, we will be frequently using these terminologies there. So I wanted to introduce them here. Okay, next let's go into the actual understanding about the today's concept, that is IoT integration with cloud services, right. We are trying to integrate them both. This is the most important one. Whatever sensors you have studied, whatever IoT Raspberry Pi or the architecture of IoT you might have studied, but today the whole IoT devices are connected to the cloud, data is being sent to the cloud, and cloud is taking care of all the processing, analytics, ML, machine learning. You are doing lot of pre-processing in that. Everything is done in the cloud, and the responses are given back to the IoT devices or the connected electronic devices to take actions. Okay, so let's understand that. I hope you have no queries till now. If anything, please let me know, right. Okay, so now this again, I hope you might have got a clear picture why this concept is important, because whatever data IoT is generating continuously, that is being pushed into the cloud, and in cloud we are doing all our processing. Whatever thing you want to take a decision, you want to run some machine learning algorithm, you want to do some prediction, you want to give some action, everything happens in the cloud computing, right. We are that is because cloud is cheaper and cloud is has lot of features. We are going to see those features anyhow, but it is much more better than traditional way of storing the data in physical machines like our laptop or some desktop machines, right. So let's dwell into this, right. So IoT, general things about IoT, if I talk in a different perspective, the Internet of Things is a complex system where hardware, firmware and cloud technologies must seamlessly work together, right. If you want to successfully implement any IoT, you definitely have to introduce cloud, right. With that only we are getting a lot of benefits. We will see how cloud is going to help us for IoT. Okay, so first one is connectivity. Getting an IoT device online isn't just about plugging in a Wi-Fi or cellular module. It is not that easy. It involves configuring AT commands, securing the communication, implementing these protocols to ensure stable, secure data flow. See, I am talking about MQTT here, I am talking about TLS SSL here, right. So connectivity between the IoT devices happens. No, the message is being secured. The protocol uses MQTT or HTTPS to ensure the data flow. Okay, so connectivity is one very important task here. Second one is cloud integration. When you talk about IoT, you have to know about connectivity. How do you connect it to the different electronic devices? From mobile to my refrigerator, how do I connect it, right? From the vehicles, how do I put a GPS tracker to a vehicle, and how am I tracking it, right? So that connectivity we have to talk about. Then the most important one is cloud integration, right? Once connection is formed between the IoT devices, okay, devices need to sync with the cloud, right? Whether through Azure or device twins or photo updates. Somehow those electronic devices should be connected and they should be in sync with the cloud, right? These systems allow for more remote monitoring, diagnostic and seamless updates. Okay, so cloud integration is very much important for us to be in sync. Then data extraction processing happens. At the heart of IoT is data. Only with that data what IoT devices are sending, we are taking some action, right? So what signals we are getting from the IoT devices, with that we cannot do anything. We have to do lot of processing. Okay, So that's why raw signals from sensor aren't useful without proper processing. Okay, you have to do lot of processing, you have to do filtration, you have to do lot of no transformations. All that is done in the cloud. Okay, so these three are important aspects when you talk about IoT. See, I am talking about secure communication, I am talking about implementing the protocols, right? And also I am talking about the photo updates. Okay, so when you are in IoT device, there is an IoT device or there is a sensor like this. This sensor which is placed at some location, it is sending data, to the cloud, right? So to send this data, and some updates needs to be done for this sensor or the board on which these sensors are placed, right? If some updates have to be done, that can be done using the photo. Next, again in continuation to that, right, the most important point here is that no, we are using IoT to solve real world problems and make a positive impact. Okay, IoT is widely used to create some impact in the our day to day life, right? Talking about cloud computing, right, one of the very interesting and most important concept when it comes about any software entity. You talk about any software project, you talk about any software application, or you talk about IoT, or you talk about any other. Today when you talk about quantum, when you talk about machine learning, when you talk about blockchain, for everything cloud computing is going to become an ultimate solution. We are not going to have any physical machines, right? What is this cloud computing? I'm just giving an overview about that. Google Drive is one place, right, which acts as a cloud for storage, right? We can store it wherever you are, any machine you log in, your data is there secure in the Google Drive. One best example of cloud is Google Drive, right? Your data is secure in that. Okay, so cloud computing involves using computer services for processes such as storing data, running applications over the internet without having to use any machines, right? So it's as simple as that. You will not do any installation of software, you will not worry about the hardware configuration of your machine. You use cloud computing platform. In cloud you can do everything. You can, today we are talking about serverless computing, right? What is this serverless computing? As a developers, we need not worry about the installation of the software. Suppose somebody wants to write a Python program, somebody wants to learn Python programming, or want to do some data science with this Python programming, right? He has to have a good machine first. Then he has to install Python software, right? Then in the third step, he has to install some IDE like Anaconda, Jupyter Notebook, some IDE he has to install. Only then he can write and run his programs, right? Write and run the programs. So this is the step involved. But cloud computing is giving you, or I mean to say serverless computing, which is a branch of cloud computing, or a advanced version of cloud computing, that is serverless computing. You need not do this. You need not have a good machine. You need not install Python. You don't need any IDE. You just log in into serverless computing. You log into any cloud platform, open that, choose the configuration you need, choose the programming language you want, write your code, test it and deploy it and run. Everything in server, we are not worried about anything. I just need an electronic device which has good internet connectivity. Okay, so lot more to talk about here. When I talk about cloud computing, all our data what we have with us, right, IoT data is being pushed into the cloud. It is like, the best example is Google Drive, right, everything. But today's cloud providers like Amazon, AWS, or Microsoft Azure, or Google Cloud, GCP, they are having so extensive features. Surprisingly, if I tell you, in AWS they have come up with SageMaker, right? They are having SageMaker. You are worried about the machine learning, somebody is working on deep learning project, they are worried about the hardware or the configuration. Their system is having 16 GB RAM only. They are unable to run the experiment, they are unable to run the model, train the model. It is taking some days, right? You just log into AWS, pay some rental. Again, I am the biggest drawback. I am sorry to say, cloud computing is not cheap. It is not free. It is cheap, but it is not free. We have to pay money to that, right? Anything, any services we want. Maybe in the second half of today's discussion, I will be showing you logging into the screen, and I will discuss about the cloud part in that, right? So we'll be logging into AWS and seeing what all features they have. So even you want to train your deep learning model, that can be done in the cloud itself. How much ever hardware is required, how much ever RAM is required, you just choose in that. It will set up for you the configuration, right? But only thing, for free we are having limited resources. No, if you pay, you need to pay rental to get no more resources. Okay, so that's about cloud. You are all aware of that. I can store my data, I can write programs, or I can implement algorithms, I can execute them, right? I can store the output again in that. Okay, your input data can be stored in cloud. You can write programs in the cloud, you can execute, run your programs in the cloud. Whatever output that programs is giving, that also you can store in the cloud, and you can deploy your applications in the cloud. Everything can be done in the cloud, right? So let's see more. What is the relation here? How IoT and cloud are going to be interacted to each other, how they are going to be work. Now we understood one thing, that IoT is generating data. IoT is giving me lot of data. That IoT data which you are getting from see, I think you might have seen some statistics that so much of millions of data, no size of data is being generated every day. IoT devices are giving lot of data to us, right? So the whole data, where can I store? Can I store in my physical machine? I don't have capacity, I don't have hardware capacity with me, right? So the ultimate solution is going to the cloud. That is one reason. One, I don't have capacity to store such huge data. Second, to execute, to do processing of the data. To do processing of the data, I don't have the capacity, right? I don't have the proper setup, whatever is required for me. Then third one is scaling. Sometimes IoT data is coming, data is coming so frequently, and I have to scale my processing, computing power. That's also not possible for me. So for all these tasks, we go for cloud computing, right? So how is it being used? First one, the first and foremost important, storage and management of IoT data in the cloud, right? So that vast amount of data that is generated from the IoT is being stored in the cloud. That is first thing. Maybe we use S3 buckets, or we use DynamoDB, we use Dynamo database, okay, to store the information into the cloud, right? That is one advantage of integrating IoT with the cloud, okay. Whereas in cloud, when the IoT data is stored, they give us some specialized services. Cloud providers are giving us specialized services for storing and retrieving IoT data, okay. So when the data is very huge, we move into the cloud. Second, cloud computing as an IoT enabler, okay. What is this? Cloud architecture itself is providing all the infrastructure required specifically for IoT, right? In AWS, we have this AWS IoT core, okay. We have this plugin, IoT button is there in that, which can help us. They provide some required infrastructure which is actually required for the IoT, okay. For these two reasons, we are integrating IoT with the cloud, right? But the foremost important one, also one of our topics of discussion, is storing and management of IoT data in the cloud. How is that? Continuous pumping of data. IoT data is every second it is generating some input, it is giving me signals, either zeros and ones. The whole data which is being generated is synchronously being loaded into the cloud, and on the go pre-processing is happening. Maybe every 5 minutes I am doing some pre-processing, I am doing some processing, I am trying to derive some patterns, and I am giving back the message. In smart farming, you are aware of the smart farming, right? The farmer is sitting at home, right? And what is the level of moisture, or what is the level of water in the soil, that he is monitoring. And if the water level is dry, he is automatically getting trigger, from which he is owning the motor. Sitting at home, he is doing this. So this is happening. Why? Because that sensors there are pushing data into the cloud. In cloud, I have written some programs, I have written some, we will be writing some functions, lambda functions we call them in cloud, lambda functions. These lambda functions will actually understand the pattern of data what is coming to us. Accordingly, they will trigger the actions. Okay, that action will be again going to the motor pump what is there in the field, which will automatically start, and water will come from the well or some other sources into the field. So this is happening through the programming part, through the cloud part only. Cloud is playing the game here. Okay, so these are few reasons why we need to integrate IoT with the cloud, and the most important one is about data, right? Data is very high, so we go for cloud. What are the benefits of doing integrating this IoT with cloud? Scalability and flexibility, right? I said scalability is one important feature of cloud. Okay, what all resources required can be automatically scaled. If you are connecting 1,000 or 10,000 IoT devices, and all these 10,000 IoT devices are generating data continuously, that whole data 24/7 which is being generated can be loaded into cloud. Okay, suppose someday only 10 devices are there, 10 IoT devices are there, that's also okay. 1 lakh IoT devices are there, that's also okay. All that data can be loaded, can be transformed. Lot of pre-processing can be done in the cloud with the help of that can be done in the cloud. That is possible because it is scalable, right? And it is flexible. You can access the data anywhere, wherever you are in the world. From your mobile phone, you can access the data. From your machine, you can access the data. Today, you are in India, you can access that IoT data. Tomorrow, you are in some other country, still you can access the IoT data. You are in US, but you have a farm, you have a land, you are doing some agriculture. What is the status of the moisture level, or what is the status of the water level you want to monitor? You can monitor it from anywhere in the world. That is possible because the data is being pushed into the cloud, and cloud is available everywhere. Why it is available? Because of that, I told you an example of Google Drive. You can access Google Drive any system. You can access it from anywhere, right? That is one benefit of that. Second, cost effectiveness, right? So suppose if I'm not using cloud, I have to have that all that infrastructure in my local machine. In my laptop I should have, or in my desktop machine I should have all those required infrastructure to handle that IoT data continuously which is coming, right? And I have to do processing, I have to run my programs, I have to execute some programs on that data to find out some insight, to derive some insight which can actually help me, right? So for that reason, this is cost effectiveness, because if you push everything into the cloud, it is cheaper, right? Better data security. Most important features of cloud computing are scalability, cost effectiveness, and security, right? Security is one very much problem, though people are working on securing IoT data in the cloud. Before sending into the cloud itself, they are doing a lot of encryption and decryption of the messages, but still cloud is secure and can be trusted. And obviously the performance, because if the data is coming in large chunks, right, it can handle and it can improve the reliability of that machine. Okay, so theoretically it looks fine, but once you build any application in the cloud and see how better it is. Lot of experiments have been done about the cloud computing. So nothing to talk about cloud here, and we don't have any drawbacks about cloud, though we have some very specific, but in concern with IoT, I would say there are no drawbacks for that. Okay, next. So again, how do you integrate that? The same thing I was talking about. The IoT devices are connected and they send that message to the cloud services, and from that cloud I have some mobile app which will keep monitoring here, right? In smart farming, you are aware of that, no? Some work is happening here, and that is the data about those functionality of those sensors is being pushed into the cloud services, and cloud from my mobile app I am able to see what the cloud is generating. Data is pushed into the cloud, cloud is deriving some insights, those insights I can watch from my mobile phone and I can take actions accordingly. Okay, so some important aspects here. So we talk about three things. One is cloud services, then the devices and the interfaces. These three things are required. Okay, we need to talk about devices, we need to talk about the interface. No, we talk about cloud services here. So what are cloud services? They are distributed large scale data storage and processing services connected to the internet, right? Some example could be Amazon DynamoDB, it could be AWS Lambda, it could be S3 bucket, right? All these are cloud services. In cloud computing, I am talking about AWS again. In Amazon Web Services, we have something called S3 bucket where we can store the data. We have DynamoDB, we can store the data, right? So three important components which play the game in IoT integration with cloud is, first one is cloud services. Those services which do the task which I need. Okay. Next, devices. So we are talking about the devices is here. We have cloud services and in between we have the interfaces. Okay, so this is how, because from this communication between these two happens with the help of interfaces. So we understood what are cloud services. There are some services, some features which are provided by the cloud providers. Okay. So device is any type of hardware that manages interfaces and communications. Devices are actually located in close proximity to the real world interfaces they monitor and control, right? So here interfaces is here, sorry, interfaces are here. From their devices, from there to the cloud, that way it happens. So what are the devices? Raspberry Pi, Arduino, right? You might know all these well versed IoT related architectures. You might have studied about Raspberry Pi and Arduino are very frequently used. Okay, so these two are well known for us. So those are devices, right? So my sensor, I have an interface. Okay, let's see what is interface here. So user interfaces, sensors and actuators, right? So from these three, right, an interface is a component that connects a device to the physical world. So in the soil I am putting some sensor, I am putting some sensor in the soil that is connected to a device. It's connected to a device. This device is used to push the data into the cloud, right? So this is what the connection flow. So these three are the most important components in the IoT integration with the cloud, right? So this interfaces are user interfaces, and then we have sensors, we know about this, and we know actuators, the output components that the device can use to control something in the outside world. So these three we have it. So devices, if you see, right, they manage interfaces and the communications with the cloud. Okay, so they are placed very close to the sensors. Suppose you are using some sensors at some location, then there is a device attached to the sensor very near to that, which can receive the information from the devices, right? We can do some computation and send it to the cloud through internet, right? You can connect Raspberry Pi to the cloud, AWS. You can connect Arduino through internet to the cloud. That is possible using the Wi-Fi, or the, you can even have SIM cards, that using the data you can have a SIM card which will provide the data to this data facility. From that you can push the data into the cloud, right? So these three are main important concepts here. Okay. So next we'll see what is the role of cloud integration in the cloud. What is the how cloud integration can benefit the IoT. Okay, we'll see this